let's take the time already to introduce our next speaker because we are now in a rush, right? We have two lightning talks, two 50-minute talks in a row. So we have now Adnan and then we have Ivan. So I'm happy to welcome Adnan here. He came over from Bosnia to give us an insight into distributed testing, obviously, right? So that distributed tracing is awesome, testing is not. He works he works for a product called Trace Test. So a short hand of applause again for Adnan. Thanks a lot. And without any further ado, I would kick it off and hand over the mic to you.
Thank you, thank you. You can all hear me fine in the back. Awesome. I have this thing that I do because nobody believes me that they actually like testing, so I always do the selfie so I can show my boss that people are actually here, so that I can validate me coming again, you know? So there we go, there we go. Okay, let's talk about some serious stuff now. So yeah, the topic for today, lightning talk, we're gonna talk about distributed tracing and how it's awesome, how testing is not really awesome, and then of course how to fix that. And let's just jump right into who I am, so you obviously, hopefully think that I know what I'm talking about. And roughly, I've been doing developer relations for 5 or 6 years, and that's basically because I failed at being a startup founder. And that's how it goes. But you know, it's just a job, and I only do it because I have to eat half a kilo of chicken every day to finance my expensive lifestyle. And with that, I think we can talk about the actual agenda for today. So obviously, as I said, tracing is awesome. That's the point why we're here today, CNCF, open telemetry. Testing, not really so much. The atomic rise of tracing hasn't really been followed by testing, so testing tools are not really there yet. And I really want to dig into why that is, and then obviously just try to solve it today. And as we know, tracing is awesome. We get observability into our systems, whether it's Kubernetes, microservices, serverless, doesn't really matter. We finally know what's happening. But if we take a look from a topological point of view, this is what a trace looks like. And then this point here is what's interesting. What if I have an external API request? Up until now, I didn't really know what was happening. With tracing, I do. And that's pretty awesome. But if we take a look at how testing isn't really cool, there is no way to test this. But what if we could use the data we get from tracing and use that in our testing strategy? So put that into our testing harness. So if we go back to this example, our black box tests will never be able to catch a problem with this external API. So what if it fails? Well, that's why I propose to try this solution. First, obviously, using CNCF tooling. We want to use Grafana for monitoring. We want to use OpenTelemetry for the distributed tracing. And then we use trace tests to leverage these traces for something called trace-based testing. So we're basically getting both monitoring and testing by using distributed tracing. And then what does that mean? Modern monitoring means that I'm using OpenTelemetry for code instrumentation. I'm able to correlate any failing request by looking at my distributed trace. And then I can drill down to exactly which span I want by looking at my Grafana, my Grafana dashboard or whatever I'm using. So I can find the root cause of that problem. Then we're moving into something that's not really there yet, but we're trying to build it, which is modern testing. So I'm going to take a trigger. I'm going to trigger my test, any API, and then I can write my assertions both on the response from that API, but also on the distributed trace that that API generates. And then I can also validate my trace data against any rules and conventions that the OpenTelemetry semantic conventions define. And here's a scenario. I have a user-facing API, so I'm triggering a post request, Pokemon import, and this is what happens in my software. I have an API, it syncs with Redis, triggers a queue, puts something on a worker, the worker does something, and adds that to a Postgres database. This is a standard distributed system, very simple, something everybody uses. And here's what it would look like in the UI. I want to add Pokemon number 6, and I know that's Charizard. Sure, it works just fine. But what if I add Pokemon 1037? Who knows which one this is? Apparently, it doesn't exist. Apparently, this all passed fine, but nothing happened. So it's failing silently, which is the worst type of failure you can get. So I start to investigate what's happening. Obviously, my unit tests are passing, which is great. My integration tests are also passing, which is also great, but still I'm seeing this problem, so I'm not quite sure what's happening. So I need OpenTelemetry, and I need Grafana to dig down into what's actually going wrong. Luckily, OpenTelemetry is simple. You just add in the SDKs for your programming language. They have auto-instrumentation. So for my Node.js API, 7 lines of code, auto-instrumentation added. I have tracing to get started. Then I need to add Grafana. And I do that by having a central collector to funnel all of my traces into. And then I use Tempo as a storage, and then obviously Grafana for the dashboard to query for my traces. And with doing that, I can actually now see what's happening. Obviously, my API seems to be fine. So my Pokemon import is all green, perfectly fine. But what is happening with my external API? This is red here. So this is throwing some errors and some exceptions, but I'm not quite sure why. But if I do drill down a bit more, I can see, yep, I have an exception here in this message, and that's my root cause of my problem. Perfect. It seems to be a GET request. I finally found the problem. So obviously, using an ID that does not relate to a Pokemon causes a chain of errors to happen. So first, the API fails silently, which is horrible. Then the external GET request fails with an exception, and then Postgres doesn't get a new Pokemon stored within it. Cool. Now, once we know what's happening, let's actually figure out a solution and make sure this never happens again. So what I do is I plug in trace test into my existing infra. I connect it to Tempo, and now when I trigger a test against my API, the same Pokemon import, I'm going to fetch the traces from Tempo, and I can use those traces as my assertions for this test. And here's what it would look like. I'm passing in, here's the ID that was the problem. I'm using it to trigger an API call. So I can see HTTP post, I have my API, so here's my Pokemon import. And then I'm obviously writing a test assertion where I want to validate that this span does not contain an exception. So my import Pokemon span should not contain an exception. Straightforward, pretty simple. I can then trigger this by using the test run command. I pass in this YAML file because we all love YAML. Just let that sink in. Obviously, I'm getting back a response. So this is any testing tool, whatever you're using, Ava, whatever you're using, you're going to get back this failed, this passed, yada, yada, whatever. But then you can also get a UI overview of exactly what that trace looks like. So you can get a tree overview and exactly find, here's my Pokemon import span, and I can obviously see something is wrong here. And that's basically it. That's how you use distributed tracing for testing. So first and foremost, you're testing against real data, so you're not using any mocks. You don't have to spend time on mocking. You don't have to spend time on writing the plumbing to actually write those 2 lines of assertions that you want to write. So you don't have any black boxes. You don't have anything that's invisible, so to say, so no unknown unknowns. Everything is visible. Everything is white box. And you can quite literally observe the system as it is. So you see exactly what it's like. You can see inside of the box, pun intended, and you can test on the real data that your system generates. And that's it. Happy to be here, and thank you for listening to my TED Talk. I mean, lightning talk.
Thanks a lot, first of all. I hope you enjoyed it as much as we did listening to you. We have still time for questions now. Are there any questions on some of the fantastic UI features you saw? Perfect. Here we go.
It takes time for the traces to come to the collector. How does trace test handle this? And also what's happening if I have sampling? That wouldn't work either.
Correct. So first part of the question, the time it takes for the trace to arrive, it all depends on the trace storage you're using, obviously. Trace test works on a principle of polling. So let's say from this example of using Grafana Tempo, trace test will look for that trace for a set timeout that you configure. So let's say I wanted to look for it for 1 minute, 5 minutes, doesn't really matter. It's going to keep looking until it finds it, or it maybe doesn't find it at all. The way that it does that is that whenever a test trigger is run, or a test is run, let's go ahead and find this. There'll be a step back. Here, so whenever this triggers a test, it's going to embed a parent span ID into that transaction. So it's going to look for that in tempo. It's going to start querying for that, and then take that parent ID, fetch all of the traces that are children to that parent ID, and then show that, very inconvenient, show that in the UI here. And then the second part of the question was,
Yes, if I have sampling on for OTLP.
so one thing you can do is that if you're already configuring sampling, you can set up another processor in your OpenTelemetry collector to look for trace test specific spans. So the parent span I was telling you about, you can make sure that whenever this particular span shows up, never sample it. That's one option. Another option is if you're running QA test environments or staging environments, you probably always have sampling enabled anyway. So this is, then it's not a problem. If you're testing against production, let's say you want to do disaster recovery testing or whatever you want to call it, something breaks, you're taking that trace ID, putting it into trace test, and then figuring out what happens, then yes, it might be a problem. Otherwise, it's not a big deal.
Did this answer your question? Perfect.
Yeah, thank you for the talk. I would be interested if there are plans or even if there are right now supported any other sources of traces. Yeah,
we have 12 integrations right now. So Jaeger, basically anything that you should be using in production is what we have.
Dynatrace?
Oh yeah, of course.
Ah.
Yeah. And I like that you were so quiet about Dynatrace, not as if like 72 people here are actually working at Dynatrace. Yeah, speak up, bro. It's fine. We have Henrik.
Cool. So it's a false question, but I'm going to ask it for the others. So you mentioned a static test with a static ID. So how can I make variables to make dynamic tests?
Ooh, that's nice.
With different data sets?
That is a nice question. So let's take the political answer here. Whatever you have in your current testing tool, so the concept of tests, test suites, environments, variables, chaining tests, all of that stuff, it all works. So features for all that is all there. So whatever you're using right now, it will work with trace test. So.
The political answer from an Austrian politician would have been much longer, I would say.
I mean, I had to, like the code of conduct, I had to be respectful of your time. Right? So.
Exactly, no, okay, cool.
And the second question is your trace is failing, let's say, so you generate JUnit report or something. How can an external tool get the results and to notify something?
So if you look at this little cog button and you click on that, it's going to say export as JUnit. You can also do the same thing within the CLI. You add a flag that says export as JUnit, and it's going to spit out the JUnit for you as well. I'm telling you, man, same as any testing tool.
That was two false questions, by the way.
Yeah, well.
It's behind you.
So the question is how to avoid writing those tests in YAML files.
Ooh, that's nice, because we all love YAML.
Yeah.
Well, you can, if you don't mind clicking in the UI, you can set up that test in the UI. Let's say you have this, as you can see, spec detail. So you basically go in there and say, I want to make sure that this particular span has this particular test spec. And then once you're done with the UI, you can go to the automate. So there's an automate button here. You go there, and then you just download the YAML file from there. So we're basically giving you all of the tools that you need in the UI for whatever automation you want to use. You can also, if you don't like using CLIs, which how many here don't like CLIs? Oh, this is good. You guys like CLIs? No, it doesn't matter then. You can run the CLI through Docker as well, so it's all the same.
Any further questions? We still have a few minutes left for one last question. How about the license or the usage of this tool? I mean, is it open source? Is there is a service component in it? Can you explain a little bit about this?
That's a valid question. So the tool itself is open source on GitHub, and so you can give it a star on GitHub. We're trying to get 1,000 stars by the end of this year. We're at 700 and something right now. So
nice.
If everybody here gives 1 star, I'll give you. I don't have any stickers, so I'll just give you a hug. Probably all I can offer. If you do not want a hug, then I don't know. So yeah.
You don't have stickers?
No, we're poor.
we have our own sticker table, by the way. So if you go to the sponsor area, right to the end, then there's a table with all the stickers, so you can fully kind of plug your MacBook or your laptop with a new cover, I would say. And we miss obviously some trace test stickers there. So next year,
I mean, if I can order some, if we can connect through LinkedIn or whatever, and I can just order you some.
cool.
And then it's MIT as well.
It's MIT.
Licensed.
Okay.
And if you want to start using it, there's basically two components. It's a server and then a web UI component, and then obviously the CLI. Right now we are planning on publishing the SaaS version, so you don't have to manage the server and run it yourself. It's just CLI connects to the cloud, and you're ready to go. So basically, very similar to what Cypress is doing.
Yeah. Cool.
And
Cool. Then thanks a lot. It was great to have you here. A short applause again, I would say.